spokes radiating outward from the center line.
That's a great analogy. Longitude lines help us determine time zones, as Earth rotates 360 degrees in 24 hours, meaning each 15-degree slice of longitude represents a 1-hour time difference.
Ah, that's why we have time zones. It's all about keeping track of time as Earth spins. This concept is crucial for understanding global time differences.
Now, there are some key parallels of latitude that are important to know. The Tropic of Cancer, at 23.5 degrees north latitude, marks the northernmost point where the sun can appear directly overhead.
So it's like the sun's northern boundary during its annual journey across the sky.
And the Tropic of Capricorn, at 23.5 degrees south latitude, marks the southernmost point where the sun can appear directly overhead.
So these tropics define the region where the sun's rays are most direct throughout the year. What about the Arctic and Antarctic circles?
The Arctic Circle at 66.5 degrees north latitude and the Antarctic Circle at 66.5 degrees south latitude mark the boundaries of the polar regions. These are important for understanding the extreme variations in daylight hours in these regions.
These circles are like the gateways to the land of the midnight sun and polar nights.
Exactly. Within these circles, there are periods of the year when the sun either doesn't set or doesn't rise, creating the phenomenon of the midnight sun and polar nights.
It's fascinating how latitude and longitude not only help us pinpoint our location, but also influence the climate and daylight patterns of different regions on Earth.
Now let's talk about time zones. You mentioned that Earth rotates 360 degrees in 24 hours, and this rotation creates the concept of time zones.
Right, as Earth spins, different parts of the planet face the sun, creating day and night. But we can't all have the same time if one side of Earth is bathed in sunlight while the other is shrouded in darkness.
Exactly. That's why we have time zones, which are regions of the Earth that share the same standard time. Most adjacent time zones are exactly 1 hour apart, with the time difference increasing as you move east or west from the prime meridian.
So the prime meridian at 0 degrees longitude is the starting point for calculating time zones. What time zone is that?
The time zone at the prime meridian is Greenwich Mean Time, or GMT. It's the reference point for all other time zones.
So if it's noon GMT, it's 1 hour earlier to the west and 1 hour later to the east.
Precisely. And India, with its standard meridian at 82.5 degrees east longitude, is 5 hours and 30 minutes ahead of GMT.
So when it's noon in London, it's 5:30 p.m. in India. It's amazing how we've divided Earth into these time zones to keep track of time as our planet spins.
And to add another layer of complexity, some countries also observe Daylight Saving Time, or DST, which involves advancing clocks by an hour during the summer months.
So it's like stealing an hour of daylight from the morning and adding it to the evening.
That's the basic idea. The rationale behind DST is to make better use of daylight hours during the summer and conserve energy. However, not all countries observe DST, and its implementation can vary.
It's interesting how we manipulate time to suit our needs. Now, what about the international dateline? It sounds like a mysterious boundary in the middle of the Pacific Ocean. What exactly is it?
The international dateline is an imaginary line that roughly follows the 180-degree meridian, which is halfway around the world from the prime meridian. It marks the point where each calendar day begins.
So if you cross the international dateline heading west, you gain a day, and if you cross it heading east, you lose a day.
That's right. It's like stepping through a time portal. The international dateline helps ensure that the calendar day remains consistent as you travel around the globe.
It's fascinating how we've created these imaginary lines to navigate our planet, keep track of time, and even manipulate daylight hours. Now let's move on to one of Earth's most defining features, our celestial companion, the Moon. I'm curious to know how this celestial ornament came to be Earth's partner in this cosmic dance. What are the theories about the Moon's formation?
There are several theories about the Moon's formation, but the most widely accepted one is the giant impact hypothesis. This theory suggests that early in Earth's history, a Mars-sized object called Theia collided with our planet in a cataclysmic event.
Whoa, talk about a bad day for Earth. So what happened after this collision?
This collision ejected a massive amount of debris into space, forming a ring around our planet. Over time, this debris coalesced under the influence of gravity, eventually forming the Moon.
So the Moon was born from the ashes of a cosmic collision.
It's amazing to think that such a violent event could give rise to such a beautiful and familiar celestial body.
It's a testament to the powerful forces at play in the early solar system. Now, there's another theory, known as the fission theory, which suggests that the early Earth was spinning so rapidly that it ejected a chunk of material that eventually became the Moon. However, this theory has some inconsistencies and isn't as widely accepted as the giant impact hypothesis.
It seems like the giant impact hypothesis has the most evidence to support it. Now let's shift our focus to Earth's movements. We all know that Earth is constantly in motion, but can you explain the different types of motions our planet undergoes?
Earth is constantly in motion, rotating on its axis and revolving around the sun. These two motions have profound effects on our lives, creating day and night, seasons, and even influencing our perception of time. Okay, let's start with Earth's rotation. How does it work?
Earth spins on its axis, an imaginary line that passes through the North and South poles, completing one full rotation in about 24 hours. This rotation is what causes day and night.
So as Earth spins, different parts of the planet face the sun, creating the cycle of daylight and darkness.
Exactly. And this rotation is also what gives us the concept of a day, the time it takes for Earth to complete one full spin on its axis. Now, let's talk about Earth's revolution, which is its movement around the sun.
Okay, so Earth is spinning on its axis like a top, while also orbiting the sun. What's the shape of Earth's orbit?
Earth revolves around the sun in an elliptical orbit, taking approximately 365.25 days to complete one full revolution. This revolution is what defines a year, the time it takes for Earth to complete one full orbit around the sun.
And the fact that Earth's orbit is elliptical, not perfectly circular, means that Earth's distance from the sun varies throughout the year, right?
That's right. The point in Earth's orbit where it's closest to the sun is called perihelion, and the point where it's farthest from the sun is called aphelion. You might think this distance variation causes the seasons, but it's actually Earth's axial tilt that plays the major role.
Ah, axial tilt. That's what I was about to ask about. So Earth's axis isn't perpendicular to its orbital plane. It's tilted at an angle. What's the significance of this tilt?
Earth's axis is tilted at an angle of about 23.5 degrees from its orbital plane, the plane of Earth's orbit around the sun. This tilt is what causes the seasons.
So it's like Earth is leaning to one side as it goes around the sun.
That's a good way to visualize it. Because of this tilt, different parts of Earth receive varying amounts of sunlight throughout the year. When the northern hemisphere is tilted toward the sun, it experiences summer, while the southern hemisphere experiences winter.
And vice versa, when the southern hemisphere is tilted toward the sun, it's summer there and winter in the northern hemisphere.
Precisely. The axial tilt is what gives us the four seasons with their varying temperatures and daylight hours. Now, let's talk about solstices and equinoxes, which are key points in Earth's orbit around the sun.
I've heard about solstices and equinoxes, but I always get them mixed up. Can you explain those?
Certainly. Solstices occur twice a year, in June and December, and mark the points when the sun reaches its highest or lowest point in the sky at noon relative to the equator.
So the summer solstice is the longest day of the year, and the winter solstice is the shortest day of the year.
That's right. The summer solstice in the northern hemisphere occurs around June 21st, when the North Pole is tilted most directly toward the sun.
And the winter solstice in the northern hemisphere occurs around December 21st, when the North Pole is tilted farthest away from the sun.
Exactly. Now, equinoxes also occur twice a year, in March and September, and mark the points when day and night are approximately equal in length all over the world.
So on the equinoxes, the sun is directly over the equator.
Precisely. The spring or vernal equinox in the northern hemisphere occurs around March 20th, and the autumnal equinox occurs around September 23rd.
It's amazing how Earth's tilt and revolution create this beautiful dance of seasons and daylight patterns throughout the year. Now, I've heard about another motion called axial precession. What is that?
Imagine Earth as a spinning top. Over time, the axis of rotation wobbles slightly, like a top slowing down.
So Earth's axis isn't fixed in space, it's wobbling like a top.
That's right. This wobble, known as axial precession, takes about 26,000 years to complete one full cycle.
So Earth is like a cosmic dancer, spinning, revolving, and wobbling all at the same time. What effect does axial precession have?
One of the most notable effects of axial precession is that it slowly changes the position of the North Star in the sky.
Wait, the North Star isn't always the same star? I thought Polaris was always the North Star.
That's a common misconception. Currently, the North Star is Polaris, but due to axial precession, in about 13,000 years, the North Star will be Vega. So the night sky slowly shifts over thousands of years.
That's incredible. It makes you realize that even seemingly fixed points in the sky are actually in motion over vast timescales. Now, I've heard about Uttarayan and Dakshinayan, terms used in Indian astronomy. What do they refer to?
Uttarayan and Dakshinayan refer to the apparent northward and southward movement of the sun in the sky throughout the year, as observed from Earth.
So it's not that the sun is actually moving north or south, but it's our perspective from Earth that changes as we revolve around the sun.
Exactly. Uttarayan marks the period from December 22nd to June 21st, when the sun appears to move northward in the sky, reaching its highest point on the summer solstice.
And Dakshinayan marks the period from June 21st to December 22nd, when the sun appears to move southward, reaching its lowest point on the winter solstice.
Precisely. These terms reflect the ancient Indian understanding of the sun's apparent movement and its connection to the changing seasons.
It's fascinating how different cultures have observed and interpreted these celestial phenomena throughout history. We've covered a lot of ground in this deep dive, from the Big Bang to the intricate motions of Earth and the Moon. It's incredible to think about the vastness of space and the intricate workings of our own planet.
Absolutely. And we're only scratching the surface of what there is to learn about the universe and our place within it.
It really is mind-boggling when you think about how everything is connected from the smallest atom to the largest galaxy. But I have to ask, what's the point of learning all of this? How does understanding the universe and Earth's place in it actually benefit us here on this pale blue dot?
That's a great question. It's easy to get lost in the sheer awe of the cosmos, but understanding our universe and our planet's place within it has very real and practical implications.
For example.
Well, for starters, understanding the Earth's motions and its relationship to the sun is crucial for things like navigation, timekeeping, and even agriculture.
Oh, that makes sense. Farmers have been using the cycles of the sun and the seasons to plant and harvest crops for millennia.
Exactly. And understanding the Earth's atmosphere and climate system is essential for addressing pressing issues like climate change and finding sustainable solutions for our planet's future.
So learning about the runaway greenhouse effect on Venus can give us insights into the potential consequences of climate change here on Earth.
Precisely. Studying other planets and celestial bodies can help us understand the delicate balance that makes Earth habitable and appreciate the need to protect our planet.
And what about space exploration? What are the benefits of sending probes and telescopes out into the cosmos?
Space exploration drives technological innovation, pushes the boundaries of human knowledge, and inspires future generations to pursue careers in STEM fields.
It's like a giant leap for humankind, both literally and figuratively. Every new discovery, every image beamed back from distant worlds, sparks our curiosity and fuels our desire to explore further.
And who knows what we might find out there? Perhaps evidence of life on other planets or clues to the origins of the universe itself.
The possibilities are endless. So to our listeners out there, whether you're a UPSC aspirant, a budding scientist, or just someone with a curious mind, remember that learning about the universe and Earth isn't just about memorizing facts. It's about expanding your perspective, igniting your imagination, and appreciating our place in this grand cosmic tapestry.
Beautifully said. And remember, exploration doesn't have to involve rockets and spaceships. You can explore the wonders of the universe right from your own backyard by simply looking up at the night sky and pondering the mysteries that lie beyond.
That's a perfect note to end on. So, as we wrap up this cosmic edition of the Deep Dive, keep exploring, keep asking questions, and never lose your sense of wonder. The universe is full of secrets waiting to be uncovered. And if you enjoyed our journey through space and time, don't forget to hit that like button, subscribe to our channel, and click the notification bell for more deep dives into the fascinating world around us. Until next time, keep your eyes on the stars and your feet firmly planted on this incredible planet we call home.